29. Any other calls?
Yeah.
Wes? Natalia, Jesus Christ, I'm sorry. My brain was in it. 21. Wes? 13. 13, 21, 29. Is that right? 13, 21, 29. That's as far as we need to go, I think. 29, Jessica. Okay. All right, let's look at number 13 first. Equations are given whose graphs enclose a region. In each problem, find the area of the region. Oh wait, no, this is 13.3. You guys don't know how to do that yet. But you will today. 13, is this x minus 4 to the 9th?
Sure.
No.
What did you guys have?
4 times the cube root of x squared.
This?
Yeah, 8x.
With, from what to what?
5 to 0.
0 to 5. Always low goes low, high goes high?
Correct, yeah.
Awesome, okay. All right, so which integral is this? 1, 2, 3, or 4?
2.
Why?
1.
Which integral is it again?
It's 1.
It's number 1. Okay, so what's my integral? 4x to the 5/3 over 5/3 from 0 to 5, which is what, 12 over 5? X to the 5/3 from 0 to 5? Good morning, Tristan. Now talk to me. Is this where you guys got lost?
Yeah,
Wes?
right on the second step.
Second step,
No,
right here?
4 was going to be attached to the 2/3.
Ah, but it couldn't, right? Because it's not the subject of the square or the cube. So it just becomes a constant coefficient that goes along for the ride. It's still 4 times this crap. This crap turned into x to the 2/3. So now it's a constant coefficient. Caitlin, what were you going to say?
How can we put the 5 and the 0 to that line figure?
Because we're doing definite integrals now. Grab your tattoo and look at the lower right-hand portion. Welcome to chapter 13.
Yay.
Yay! Okay, so now we just plug and chug, right? So now we have 12 over 5 x to the, or sorry, 5 to the 5/3. That's f of b minus 12/5 0 to the 5/3. So this is my f of b minus f of a, right? That's all we're doing here. Plug and chug. And for those of you that need a reminder, you can check your answer in your calculator. You can do function int. Open parentheses. And then in those parentheses you would do open another set, 4x caret to the 2/3. I would parenthesize that just in case. Close parentheses, comma, with respect to x, comma 0, comma 5. Close your parentheses. And that should give you your answer. That's a caret. It's an ugly caret. There we go. And those of you that don't get that version, you get this version. Well, you guys should really by now be able to fill that in. This is a 0, this is a 5, this is a 4x to the 2/3, and that's an x. And I'll give you the answers. So Caitlin, let's see, how many of you weren't here? Haley, Marco, Caitlin, Ty, grab your calculators. You're getting the 30-second catch up to what we learned last time. Naughty, naughty. Oh, Emma? Emma, you too. So function int, you get that from the math button. Hit the math button and you're gonna arrow down to f and int. And you're gonna get one of these 2 versions. Which version do you get, Marco?
Bottom one.
The bottom one, lucky you.
Wait, I don't have a match button.
Yes, you do. Marco, show it to her.
Sorry, okay, now where? This.
Arrow down to function int and hit enter. And it's gonna give you one of these two versions. Once again, if you get this version, you must plug your function in, inside parentheses, close your parentheses, hit comma, with respect to x, comma, from x equals 0, comma, to x equals 5.
What is that little arrow between 2/3 and the?
It's a caret.
So you like put that in?
For your exponent, I'm just writing this
Oh.
stroke for stroke,
Okay.
okay? 4x to the 2/3 goes in this if that's what you got, and you guys know how to do this, okay? So welcome to,
Wait, so it either shows the top one or it shows the bottom one?
yeah,
Okay.
so whichever one it shows, you put it in like you see it. So any questions on this one? How many of you guys were practicing checking your work with the calculator? Anybody? Yeah, yeah. Did you find that to be useful? Hang on, Caitlin. Did you find that to be useful?
I did.
Awesome, good. Okay, Caitlin, what's up?
No, I was just wondering, what's the final answer?
The answer's a number,
Yeah, so-
35.08.
But that's just plugging in
35.08.
the original.
Yeah, if you were to do this math, you would get 35.08 amps
So
out of it.
once we get that, we can just plug it in our calculator?
Yeah.
Or are we supposed to
Yeah.
like, do the math from there?
No, this is as far as I need you to take it, and then
Okay,
you can do it in your
plug it
calculator.
calculator.
Yeah, that's it. Moving on. You guys can consider yourselves marginally caught up. Read your handouts if you're stuck. Groovy. All right, so now, number 21. I have 4x plus 9 under a root from 0 to 4. Oh, what do you have, Wes?
X cubed minus 3x squared to the third, in parentheses, x squared minus 2x dx from 2 to -1.
Like this? From -1 to 2?
Yeah, I'm gonna keep saying it backwards, but.
Yeah. Always read from left to right,
Got it.
so low goes low, so your low number is gonna be read first. Okay? So which integral is this, 1, 2, 3, or 4? I heard number 1, that's not right. Which is it? 2. Why number 2?
Power tied to a function.
We have some u to the n times maybe a u prime. So what's our u? And what's our u prime, guys? And what do we have?
That.
And what do we want?
That.
So what do we multiply and divide by? 3. Will that give us what we need? Yeah. Ken is on it. It clicked, didn't it?
Because of your help.
Make appointments with me. They are filling up really fast, guys. Okay. All right. So now, what do we multiply and divide by? Yeah. So I'm going to skip to the good stuff because I'm going to keep the 3 on the numerator and deny the 3 on the denominator. So I'll end up with my 3x squared minus 6x is my u prime. My u to the n I'm going to shift to the back so it's in proper format. But it's not necessary. Do whatever floats your boat. Oh, and this is from -1 to 2. So now we have 1/3 x cubed minus 3x squared to the 4th over 4. And we're doing this from -1 to 2. Okay? Yeah. So now what?
Plug and chug.
Plug and chug, peeps. What goes in first?
The negative, or the 2.
The 2. So we'll have 2 cubed minus 3 times 2 squared, basically, to the 4th power, divided by 12, right? Because 3 times 4 is 12. Minus, gosh, -1 cubed minus 3 times -1 squared, all to the 4th power divided by 12. I'm bored. 2 cubed cubed is 8, 2 times 2 is 4, 3 is 12, 8 minus 12 is negative 4 to the 4th power over 12, minus negative 1 cubed is negative 1, negative 1 squared is positive 1 times 3 is 3. So negative 1 minus 3 is negative 4 to the 4th over 12. Great. You have a thing minus itself. What are you going to get as your answer? Damn straight. Is it 0?
Yep.
Yeah, it is. Okay, so once again, you can do all of this without your calculator. Groovy? Okay. Don't overthink it, guys. Brooke, your light came on too, didn't it? Yes. Teacher crack. Any questions on 21? What was the hardest part? Natalia, did you ask for this one?
Yeah, but I have the other version.
You're the other son of a. Why didn't you speak up?
Because it's fine. It's fine.
Does it make sense?
Yeah.
Yours is going to be integral number 2 as well, where u prime is going to be, I believe, 1, right? It was 20. What did we do? Yeah, your u prime should be 4, so you're going to have to multiply and divide by 4. But same. Groovy?
But once again, we can stop where you stopped with the blue and plug it in our calculator.
Yeah, and plug it in your calculator to get the answer. But I need to see every step like this.
Up to the blue.
Up to this. Yeah, I need to see that you plugged in everything in the right place, the right way. Parentheses are going to start mattering, guys. Signs are going to start mattering. Marco.
For the top line
Yeah.
in blue, how did you go from that to next?
From this to this?
No, the one that you pointed at first.
From here to here?
No, that one to the one.
That's the integral, dear.
Oh, okay.
This is u prime u to the n, right? So constant coefficient goes along for the ride, and we've got u to the n plus 1 over n plus 1. And instead of plus k, we now incorporate the definite integral. So those of you that missed that part, notice there's no k in your integral. It's gone, right, Haley? All right, so number 29. Let's take a look at that one. Who asked for this one? All right. Did you guys all have 8x squared e to the negative x cubed? Okay, what did you guys get? What? 4 over z with respect to z. From what to what? From 1 to e. From 1 to e? Okay. From 1 to e, and we have 4 over z with respect to z. Groovy. So make it pretty. 4z to the what? Which makes this integral number 4. What's my u? It's z. What's my u prime? 1. What do we have? What do we want? So we're going to pull the 4 out and get us 1z to the negative 1 from 1 to e with respect to z, yes? So now we have our u prime u to the negative 1, right? What's my integral? For natural log of what? Yeah. And we're going from what to what? Plug and check, guys. 4 natural log of e minus 4 natural log of 1. Well, you guys should be able to do this in your heads, believe it or not. Natural log of e is the same as,
Where is that? Not for natural log of z supposed to be an e, or is that?
I'm plugging my f of b minus f of a. Hang on, I gotta answer one at a time. Adam?
Did you hear my question?
Yeah, I did. I'm
Okay.
saying that it's not 4 natural log of z anymore. We're plugging f of b minus f of a. Here's your b, here's your a.
The
Caitlin.
letters are confusing.
Why'd you put a natural log with the 4 natural log of z? Like, where's the natural log coming from?
It's coming from the fact that this is u prime u to the negative 1. Negative 1 indicates it's integral number 4.
Oh, right. Okay.
Yeah. What's 4 times 1? Minus 0.
4.
That's your answer.
Nice.
You don't need a calculator for this one, guys. Because you know this stuff already. You know natural log of e equals 1. You know that. You also know that natural log of 1 equals 0. You know this stuff. But should you need to shove it into your calculator, I'm perfectly happy if you plug in this into your calculator. Okay? How would you check your work?
I plug in the original in the box.
Yeah. So 4 divided by x with respect to x from 1 to e. And yeah, you can plug an e into your calculator. What power do you give it? Because it's going to ask you for that.
Oh,
Yeah.
Wait, can you go for?
Iman, does it make sense? You asked for this one? Okay. Kenna, you also asked for this one?
Yeah.
Okay, who else asked for this one? Talk to me, guys. Does this make sense? Kenna?
Now it does, yeah.
No, it does. It's just too simple, right?
Yes.
That's probably what threw you. You were like, this is too easy. I don't know what goes where. Remember, the subject of the -1 is just z. So that's going to be the subject of your natural log. That's the easiest place to put that. All right. How do you guys feel?
great.
Ready to do the area between two curves?
No.
Yes, you are. Yes, you are. It's just a riff on this, guys. It's just a riff on what you already know.
We're doing 13.3.
13.3. This makes, after today, we will have 3 more lectures. You heard that right, 3 more lectures after today. I expect to see every single one of you in here from here on out. I mean it.
What about auto?
Mem, are you recording today? Oh, thank God. I just want to tell all of you that I'm going to give you a mnemonic today that's going to sound really filthy, but it's not intended to be. Okay? The mnemonic refers exactly to what I'm going to put you on the board. But you can use your dirty little minds to...
Is it like when you said jump?
Yeah. Don't touch the jump, right? This is a mnemonic that's going to help you to remember something. It's going to sound really filthy, but it really makes sense. So, what? Not intending it to be, though. Seriously, guys. 2, 4, 6, 10, 11. Just caveating this. So don't get upset with me. 4, 5, 8, 11.
Hearing from my mom and dad.
4, 6, 8, 9. And if your mom and dad try to write to me, I'll be like, I can't even confirm that your son and or daughter and or person is registered at this school. So talk to your lawyers, but I'm protected by FERPA and so are you. What was I saying? 4, 6, 8, 9. I can't even talk to your parents, you guys. If your parents call me to complain, I'll be like, welcome to college. You're adults. I'm Oh, yeah, I've had parents call me before.
What's Ryan making his man? You better be making at least
Helicopter
a
lunch?
stage.
Welcome to my world. This is why I don't teach high school. I don't have to deal with parents. In fact, it's illegal for me to deal with parents, so yay. So great. Okay. I want you guys to look at page number 1. This is important. Which function is on top? Is it F or G? F's on top. Whoever's on top comes first. That's your mnemonic.
Whoa, whoa, whoa.
And I have your attention. Welcome back, chickens. So, when we have two functions, let's call them f and g. Doesn't really matter. Woohoo! Here's f. It's not. And here's g.
Okay.
It's not.
I trust you.
And we want to find this area right here. I don't care what the functions are. Who's on top? F. F comes first. So here's the integral. We do top minus bottom. That's why the top comes first. Over the region from A to B with respect to x. It's that simple, guys. I don't care what kind of functions you're working with. Top function minus bottom function. Whoever's on top comes first.
Whoever's on top comes first.
Yes.
You're right.
I
Yeah.
don't get it.
Oh my God.
As you were.
Explain.
Have your parents call. I'll be like, did you not? Okay, anyway. So,
You couldn't teach high school because you.
I couldn't, I would get so in trouble. But honestly, guys, I want you to treat this like it's a genuine mnemonic because it is. The top function comes first in this scenario. It's always top minus bottom. So take it how you want it, but it's a genuine mnemonic, okay? But sometimes, oh dear God. Sometimes they switch halfway through. So let's say we're going from A to B now. Here's B. And this is the area we're looking for. And let's just call this, well, let's do A to C. And this is B. Okay, and here's G up here. Does your function change as well? So halfway through, so who's on top from A to B? F. So this is literally going to be f minus g, right? So this is the integral from A to B of f minus g with respect to x. And then this interval, you're going to add them together. I know this is really tight, guys, but bear with me. From B to C, who's on top? G. So it'll be g minus f over that region with respect to x. So I'll write it out up here. So from A to B, it's f minus g, because f's on top in that region, okay? And then we add the second region from B to C. Well, g's on top now, so it's g minus f with respect to x. So let me erase the mess I made down here. It doesn't matter what the functions are, does it? It's one function minus another. And the hardest thing you guys are gonna have is remembering to subtract the entire function, which is like when we subtract cost, we subtract all of cost, distribute that negative sign. So now you have to remember to subtract the whole function, okay?
What do you
That's-
mean by that?
Yeah, so if I have, let's just say I have x cubed plus 6x squared minus 8 minus x squared plus 6x minus 5. When I subtract this function, all of my signs are going to change. This has become minus x squared minus 6x plus 5. My second function is going to change sign all the way across. Don't
that
just
the-
subtract the first term, subtract everything.
Is that like the integrated, as if it was already integrated right there?
No, this is, so say where we're setting up some region, right? Where this was on top in that region and this was on the bottom. Then we're trying to make our integral as easy as possible. So we're gonna combine functions before we try to integrate.
Okay, but how come there's this subtraction when you had it
So,
plus?
so that.
It's the
that first
formula,
parentheses
honey.
is
It's
G's.
top minus bottom.
The parenthesis is G.
take a look at,
Okay.
okay?
Yeah,
So
yeah.
do you guys know why it's minus? That's the next question. Why is it minus? Look at your handout. So if we take this area and we subtract out that little area, what we're left with is the area we want. So think of this as blocks, right? If we take this block and we cut that shape out of it, what we're left with is the shape we want. That's literally subtraction. So far, so groovy. So that's why the sign in between them, Caitlin, is negative.
Yeah,
So
I
would the-
get it now.
Okay.
X cubed be the F and like
It
X
would
squared
in
be
this
the
case.
G.
I just haven't set it up as a region between blah, blah, blah,
Okay.
because I don't know for sure what's on top.
Okay.
So I'm just,
That's fine.
for illustration. So we're gonna do some real problems. Yeah, Adam,
And so I'm confused on the top part, right, in the black.
right here,
Yeah,
where are you stuck?
it's like the plus, so like, what is that exactly? Like, do you-
Why are we adding? For the same reason we would add areas when we're finding areas, right? You just add them together.
So
What's
that's-
this area plus this area? That gives you the total area that you're looking for,
Oh, okay.
right?
Mhm.
Okay, Caitlin?
I actually raised my hand for this.
Yay.
So that's always add and the inside, the F and the G.
Right.
Those are always subtraction.
So this is an area plus another area gives you total area,
Right, but
right?
it's always gonna be like, wherever there's a minus, there's always a minus, wherever there's a
Plus, there's always a plus, yes. This is the way this goes. So it's area plus area. To get the area, it's top minus bottom. Okay? And this is set in stone, guys. It's not on your tattoo, but guess what? You can add it to the back. Yep. Top minus bottom. So let's do some math, shall we? Yeah. I know, it seems like a dirty mnemonic, you guys, but it's not intended to be. But it does help you to remember it, right? Yes. You all sound so disappointed. It's freaking hot in here. Am I alone here, or are you guys all cooking too? It's hot. Area between two curves. Yay!
So what we're here with the-
So we'll start nice and easy. I want you to find that shaded area.
For the homework, are they gonna give us graphs like this? and-
Yeah.
Okay.
Yeah, there will be several different kinds, so I'm gonna give you as many of the kinds as I can within the time we have, so that you can see them all. Okay? Who's on top?
X squared plus seven.
Yep. So how do I set this up? Top x squared plus 7 minus our bottom, which was 1/2 x. We're integrating that from what to what?
0 to 7.
0 to 7. That was easier than you guys thought, wasn't it?
Yeah.
Top minus bottom. Okay?
So you don't need like the parentheses, like how you
No.
had them on the first.
No, when you're subtracting a 1/2 x, you're subtracting a single term. So the parentheses are not necessary. But if you want them, just for continuity, so that you are doing the same thing every time, by all means include them. Okay? So is this integral 1, 2, 3, or 4?
1.
1. What's my integral?
Yeah.
I'm gonna cry.
Now, if you have the x squared plus
All right,
7 in
x-
parentheses and then the 1/2 x, then it would still be
X to
integral
the
number 1
third.
because neither is raised to a power.
That's right.
X to the third
Yeah?
plus 7x.
No, over 3.
Oh, yeah, over 3.
You guys have forgotten how to integrate.
It's a long
7x
day.
minus 1/2 times,
X to the second over two.
thank you. Yes, from 0 to 7. Okay, so let's clean this up a little bit before we start plugging crap in. X cubed over 3 plus 7x minus x squared over 4 from 0 to 7. I'll let you guys stare at that for a second. What do I do next? Plug it in? Plug what? Plug what? Plug what in? 7. Okay. So here's 7 cubed over 3 plus 7 times 7 minus 7 squared over 4 minus, and I can go through and double check each term and verify that each one of them is going to go to 0, but I need to see at least that, you guys. You know what I'm talking about. Don't assume that every term is 0. You must go through. Just because you're plugging 0 in doesn't make the whole thing 0. You must go through and verify. Just like we did when we found K, right? Gesundheit. So now we can do a lot of this in our head. Let's make it just a little bit simpler. We've got 7 cubed over 3 plus 49 minus 49 over 4. Right? So what's your answer? Gesundheit. Who's getting a workout?
151.08.
How would you verify this, guys? What would you plug into your calculator, though?
The original.
What original thingamabob?
X squared plus 7.
So you have to get as far as plugging it in, top minus bottom. So you need to know what's on top. How about if I don't give you the functions in a picture? How can you tell who's on top?
Whoever comes first.
What?
Whoever comes first.
Yeah, but how do you figure out who's on top? If I just give you 2 functions in a region, and I don't give you a pretty picture, who's on top?
Set them equal to each other.
No, that'll tell you if they
Oh, that's
connect.
the
These 2 are
interface.
never gonna
You
connect, though.
graph them both
Yes. Graph them.
together, right?
Yeah, graph them together and see who's on top. Right? Over your region from 0 to 7 in this case.
Like, the one would go into like Y1 and then the other one would go into Y2.
Precisely. Yep. When in doubt, graph them out, guys. If you don't get a picture and you want to know who's on top, graph it and look at who's on top.
Is there another easier way to know who's on top, or
Well-
you have to graph it?
Sort of. If they give you the region from 0 to 7, so let's just say they give you this function, and from 0 to 7, and they don't tell you anything else including the picture. Find a test value between 0 and 7, like 1, and plug it into both, and whoever gets a higher y is on top, right? So you can do this algebraically too if you want, but when in doubt, graph it out. You guys need the graphing skills, right? Let's do another. Oh, they're so pretty. Oh, shit, the notes are so pretty. This time I'm going to give them to you without a picture. So I'm going to give you y equals 2x and y equals x cubed minus x squared. So y equals 2x, y equals x cubed minus x squared. Find the area bounded, and this could be area or areas bounded by the 2 functions.
squared away?
I don't know.
You're gonna make this find zeros.
Oh, you have to set them equal to each other.
Algebraically, yes. How would you do that?
Getting
Yes.
all of them to one side and then factoring.
So this is method 1. Right? So 0 equals x cubed minus x squared minus 2x. What can I factor out of all of those?
The x squared.
How about just an x?
Or x, yeah.
Okay? So I get 0 equals x times x minus 2, x plus 1. So I get x equals 0, x equals -1, x equals 2. They intersect at 3 different places, guys.
Oh, jeez Louise.
So they're gonna flip probably, aren't they?
Probably.
So they're gonna trade halfway through and another one's gonna,
Come first.
yeah. So if you graph it, what should your x min and x max look like? You can use this as a guide. Yeah, you should at least go to -1, maybe past it to -5. And how far out should you go on x max? Somewhere past 2. So let's just go from -5 to 5.
Are we taking a step back to what we first learned?
Yeah, this is all tied together, guys. That's why it builds on itself. So here's what we get. We get 2x looking like this. And we get x cubed minus x squared looking like that. Oh boy. So when you graph this, you're gonna see something that looks approximately like that. Groovy?
So we'll actually need to like graph this on the calculator, draw it out.
Very likely, yeah.
Figure it out.
Yep, welcome to your graphing nightmare.
Yay.
But it's gonna make you better graphers, so. It's good practice. So now let's set this integral up, shall we?
Is there another method to find out where they intersect?
Absolutely, you could graph them and look for the intersects in your calculator. You use second trace and then intersections. Do your left-bound car, your right-bound car, and make them smash, okay? But that's actually slower in this case than the algebra.
I'm trying to graph this and my calculator keeps saying error.
Error? Error, what kind of error?
Like it just says like error clip. Like, you know.
No, it'll give you error more than that. Error boundaries, error range, error something.
Doing it when I do my window.
See, it says window range, so it's not just like an error. Go to your window. Check first. You're going from -5. Your min and your max y are the same.
No, I should.
There you go. No, minus.
We shot that cost.
Never.
Yeah. Liquid lines.
For what?
Stuff. Okay, so who's on top in the first region?
Wait, and then you said to find the points where they're intersecting right there, so you know
Yeah.
like the.
So you can do that in your calculator using second calc intersect, just like we found zeros before. So algebraically, I've already found them to be 0, -1, and 2, so I can label them just for giggles. Here's -1, here's 0, here's 2. So how do we set up this integral, guys? Who's on top of the first region?
2x.
So from -1 to 0, we're gonna do not 2x,
Oh, sorry.
x cubed minus x squared minus 2x with respect to x. For the second range, or the second interval, from 0 to 2, who's on top? So 2x minus x cubed plus x squared with respect to x.
Why is
Wait,
it
why are you
plus?
now that
Should
should
be.
one?
Why is it a minus between x cubed and x squared?
It's right.
Yeah, 'cause you
Do you guys see
factored out
why?
the negative.
Distributed.
I distributed the negative. Yeah, good, Marco. And everybody else that caught it. Blaine. See you back there. I see you. It's still top minus bottom, guys.
So if we did,
Okay.
the control step would be minus 2x
Yeah.
minus or plus 3x.
In parentheses, this would look like x cubed minus x squared minus 2x. And this would be 2x minus x cubed minus x squared. Wouldn't it? F of, or top minus bottom, always top minus bottom. Riley? No? Talk to me. You're good? Okay. Adam, and then Tristan,
So, how,
and then Corwin, I saw your hand too. Hang tight.
how
Adam.
is this different from the last example? I'm just confused with the plus sign and just this whole thing.
What plus sign?
That.
This?
Uh-huh.
We're adding two areas together. So area one area
Uh-huh.
plus area of the second area.
Okay.
So here's area of the first area
Uh-huh.
plus area of the second area.
Oh, okay, I see. Because they're
Okay.
on two different quadrants.
Good.
Okay.
Tristan, and then Corwin.
So if it's some crazy function like x to the 7th and it crosses like
Yeah.
10 times
It's not
or
gonna
whatever.
do that, but yes,
And then
technically you
you
could
just keep
totally
adding
do
and
that.
flipping and adding and flipping.
Blip,
and-
blip, 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 exactly. Corwin,
Why is the first intersection put a -1? Because when I calculated, it's a -2.
-2.
And that's my calculator.
Did you have your signs right? Because this will give me the factors of -2 that give me a -1 in the middle are -2, +1. So this gives me a +2 and a -1 when I set them equal to 0.
Oh, yeah, my mistake.
Does that make sense? Are your signs off?
Yeah.
Yep. Yep, if you switch these, that's gonna change everything. Yeah, you're welcome. All right, how do you guys feel about this? The setup is the hard part. These are integrals you guys already know how to do, okay? So I'm not gonna waste your time with the integration, because that's something that should be pretty close to automatic by now, especially since you know how to plug it into your calculator and check your work, okay? But the setup is the hard part, right? You wanna look at another one?
Yeah, sure.
Okay. Does everybody have it? Do they want photos? Or do you, I'll just start over there.
Integrate from that.
Autumn?
Then you integrate those two,
Mhm.
and then from there you plug in 0, -1, and 2 and 0.
Yeah, so it would be f of 0 minus f of -1, and it would be f of 2 minus f of 0.
And then you add them together.
And you find your areas and you add them together. Signs are important here, guys. They will eat you alive.